Alright guys, welcome back to Underground Science, and in this video we're going to talk about the mechanism of the acid catalyzed hydration reaction. So let's go and get started. So we know we are reacting this, right, this alkene with the hydronium, and so let's go over the mechanism, step-by-step mechanism, how this works. So if we go and draw the reactants out again, or the reactant out again, and let's go and draw out all the bonds of hydronium. So that would look something like this. Right, so it has a positive charge on it. And so that's hydronium drawn out fully and the reactant drawn out fully. Now let's draw the arrow pushing. So let's draw where the electrons are going and where the bonds are being made in red. Okay, so we're going to draw, first of all, what do we always say first? What do? We identify what's the nucleophile and what's the electrophile, right? Nucleophile is electron rich. Electrophiles are electron poor. So if we look at this molecule right here, we have a high electron density here because it's a double bond and bonds are made up of electrons. So this will be the nucleophile, and this is positively charged, indicating it's electron poor. So this will be the electrophile. Okay, so if we see how this works, this nucleophile will attack this hydrogen, and then these electrons will go in the oxygen, making water. So what we're going to have next is like this. It'll look something like this, in which we made this hydrogen bond to the carbon, and then we're going to have water now, right? Since these electrons came to the oxygen, so this positive charge goes away. So that's water, and then remember, we took an electron away from this carbon because this is two electrons, one here, one here. These electrons were used to make a bond with this hydrogen, so that means this carbon lost an electron. So that's this carbon right here. So that if you lose a negative charge, you become positively charged. So we have a carbocation intermediate. Okay, next, do the same thing. What's the nucleophile? What's the electrophile? This looks like the electrophile to me, right? Because this is electron poor, it has a positive charge. So it's basically an empty p orbital, makes it a good environment. An empty p orbital and electron poor, right? So we know that, okay, the water it now has to be the nucleophile because we already know this electrophile. And because it's an empty p orbital, we've mentioned this in previous videos, water can either attack from the behind or it can attack from the top. So from the bottom or the top. So if we're talking about specifically 3D, right, we can either end up with a wedge bond or a dash bond. But we're not going to go over that because we're just trying to get the basic mechanism down. Okay, so let's say, so water is going to be the nucleophile, so water is going to attack this empty electron poor p orbital on that carbon. So we're going to have something like this in the next step. Now all we have to do is just get rid of the positive charge. And so if we remember, how did we get this as our acid, right? And how do we get this part of our solution? So what we did was we reacted a bunch of water molecules with sulfuric acid molecules, right? And so specifically, we should say sulfuric acid with two hydrogens, right? And then we got hydronium. And then of course, we got the conjugate base to this, which isn't that important right now. We'll write it out. But the main thing that we're focused on is we got a bunch of hydronium. But how did we get this hydronium? Because we have a bunch of water molecules in solution. So what's going to happen is, because we have a bunch of water molecules, a water molecule, right, is going to come here, part of this reaction mechanism, right, part of this step, and will actually attack this hydrogen, and then this single bond will break, and those electrons will go in the oxygen, the more electronegative atoms. So that's good, right? Because electronegative atoms love having electrons. So what's going to happen is now we're going to have our product, which is going to look like this, and we're going to have OH here. And then because this water, right, attacked the hydrogen and gained a hydrogen, so this water gained a hydrogen, it's going to turn back into hydronium. So that's going to look like this, right? And see what happened is we gained back our catalyst because our catalyst was the acid, right, which is the hydronium. So one important thing to note here, And before we move on, right, so this is our product. It's the addition of water, so OH and H, across this double bond, and with the help of the acid catalyst, hence called acid catalyzed hydration. Okay, and so one important thing to know is we regenerated our hydronium. So that means catalysts do not get used up in a reaction. Okay, so that's an important trait of catalysts. All right, so that's it for this video, and in the next video we'll go over different types of hydration examples, and I hope to see you guys there.